Okay, Bismillahirrahmanirrahim. Today our topic is breakdown in liquid dielectric. Okay, so the liquid as insulating material, liquid dielectric are more useful as insulating material than either the solids or the gaseous. As compared to the gaseous, they are useful because they have the higher dielectric strength as compared to the gaseous, while uh, as compared to the solids, as the liquid are fluids, uh, same as the gases, so there is a property for the fluid that they can flow. So if any point of the liquid dielectric has been break down, so it will not increase just as it is increased in the solid. In the solid we can see that if any point is has been partially break down, so it gradually increases, but which is called string. But in because it cannot flow to other place or other point, while in liquid, if this point out of this whole container, this point has been um, breakdown, so it may be shift to some another point, and a fresh molecule can replace this because of its flowing property. So this is the advantage of the liquid dielectric over solid, and having very less difference in the dielectric strength, almost the same. Okay, so liquid and solid are usually 10 is about 3 times denser than the gases. So oil is about 10 times more efficient than air or nitrogen in its heat transfer capability when used in transformer, because in transformer we are using the oil for two purposes: for the cooling purposes, and second is the insulation purpose. Okay. So if we used air cooled transformer, so air cooled is not as efficient and cannot provide as much cooling uh, as the oil can provide, because the oil has good heat transfer capability. Okay, and liquid are expected to give very high dielectrics of the order of 10 megavolt per centimeter, means for the distance of 1 centimeter, uh, if we apply uh, 10 megavolt, so it can withstand 10 megavolt for the space of 1 centimeter gap. But usually due to some contamination and external sources, the breakdown we practically obtained is 100 kilovolt per centimeter, means zero point 0.1 megawatt. Okay, so mostly commonly used liquid insulating oils are mineral oils, and which is used in transformer oil, the n-hexane, n-heptane, and castor oils, silicon oils, transformer oils, and liquefied nitrogen, etc. Okay. Okay, so the major impurities, I have discussed it in the previous slide, that due to some impurities its breakdown can be affected. So the major impurities in liquids are the dust, the carbon and sulfur ions. The carbon ions are obtained by when, for example, in circuit breaker, if we have these are the contacts of the circuit breaker, and this is oil. Okay, so when a fault occur, it will open and arc will be created, and the arc will be quenched by the oil. So uh, this arc can actually causes the, the, the carbon particles as the oil is burned out. It means that oil is burned out by this arc, so the carbon small particles will be created. So these will actually acts as impurity for the liquid, and it will reduces its dielectric strength. Okay. Okay. uh, Water particles means water droplets, water vapors. Okay. Water acts as the moisture, and the water particles droplets, these actually acts as insulating impurity for the liquid. Okay. And badly, we will discuss in this example that it can badly affect the dielectric strength of the oil, the liquid dielectric. Okay. Some ionic particles, okay, and dissolved gases means bubbles, etc. Carbon dioxide, dissolved carbon dioxide, just like in coke. Okay. In coke we have the dissolved carbon dioxide. Okay. So gas can be dissolved in liquid. The presence of E1.1% means out of the 100 we have only 0.01 particle. Out of the 100 particles we have only 0.1 particles of water in transform oil. It can reduce its dielectric strength to 20%. Presence of this much droplet in transformer oil can reduce the electrical strength of the oil to 20%. If it was 100, then due to presence of 0.01% oil, it is reduces to 80. 20% loss. Okay. Liquid dielectric are used mainly in high voltage cables. Okay. In capacitors, for filling up the transformers, the circuit breakers, etc. Okay. Liquid dielectric also acts as a heat transfer agent. I have already told you. Liquid have many applications. Heat transfer agent, the arc quenching in circuit breakers, and as a insulating material. Okay. Okay. Properties of dielectric material. The few properties are the one is permittivity. Okay. It is the ratio of electrical flux density in the material to produce the free space by some electrical force. Okay. So permittivity, as we uh, according to the formula, E is equal to epsilon naught d. So epsilon naught is actually the ratio of it is d is equal to epsilon naught E. Okay. So epsilon naught will be equal to d over E, electric flux density to the electric field intensity. This is actually talking about this. Okay. The capacitance of a capacitor is directly proportional to the permittivity. Okay. As we know that C is equal to Q by V. This is one formula, and the second formula is epsilon A over D. Okay. Equal to epsilon is the permittivity of the medium placed between the capacitor. A is the effective area of the plates, and D is the separation between the plates. This is actually the D. Okay. And the area is actually, this is area A, and the medium placed between these two, this is actually the permittivity. Okay. So the capacitance means is the ability to store the charges, the electrostatic charges. So C is directly proportional to permittivity, it is also directly proportional to area and inversely proportional to d. So we are talking about the permittivity. Okay, so if we have a good dielectric placed between the capacitor having the high dielectric having high permittivity of the medium, then we will have increased capacity for the capacitance. Okay, and if we have low permittivity for the dielectric medium, then we will have low capacitance of the capacitor. So the permittivity of the dielectric material should be high in order to get the high capacity for the capacitor. Okay, the second property of the dielectric material should be high dielectric strength. Okay, so the definition of the dielectric strength is that how much uh, voltage it can withstand. Okay, how much electrical voltage it can withstand, this is called the dielectric strength. The greater is the dielectric strength, the greater a larger amount of the voltage it can withstand. Okay, and it is expressed in volt per centimeter, kV per centimeter, or megavolt per centimeter. Okay, so dielectric strength is actually the major factor that can count the quality of the dielectric material. So there are few factors that depend upon the dielectric strength. Number one is the temperature. The dielectric strength decreases with increase in the temperature. Okay, because as we have studied in the previous lectures, that there are few stresses on the dielectric material which can reduce its insulation property, and one of these stresses was temperature. There were the environmental stresses, the electrical stresses, and few more, but one of them was temperature. So it means due to high temperature there will be high stress applied to the insulating material, and the dielectric strength will be decreased. In high temperature, electrical breakdown occur at lower amount of voltage. Due to higher temperature, particles get loosely bound to another. Okay, so it means for good insulator, and the insulator must have high thermal stability. Okay, the particle become unstable, and breakdown can easily take place. The second point that affect the dielectric strength of material is the moisture, as we have studied in previous slide, that 0.01% of the moisture reduces dielectric strength to 20%. Okay, the third one is the time lag. Time lag is the time span or taken by any insulator to completely break down. Okay, so the dielectric strength withstand higher voltage for short time or short time lag. It means higher the voltage, lesser will be the time lag, mean it will take less time to break down. Frequency, dielectric loss is directly proportional to the frequency of the supply. Permittivity of the liquid dielectric is inversely proportional to the frequency. This means that for higher frequencies the dielectric strength, the dielectric losses will be high, and for the high frequencies the permittivity of the liquid will be low. Okay, these are inversely proportional. Okay, now short key losses are not the part of the course. So breakdown in liquid, suspended particles in liquid or impurities present in the liquid. Okay, so what are the suspended particles that are present in the liquid? That are carbon particles, the sulfur particles, the ionic impurities. Okay, and ionic impurities are the result of some chemical reaction. Okay, fourth one is water droplets and water vapors. Okay, as you know that a breather is installed at the start of the transformer, so that if any of the as the air is circulating through the conservator, so the air should be passed through the breather, and in the breather we have the silica gel having a sky blue color. So as the property of the silica gel is to absorb the water, so that a moisture-less air is passing through the conservator of the transformer. Okay, so the color of the silica gel indicates that now it has lost its property of absorbing the moisture, so it is then replaced. Okay, so this is because water droplets or the moisture, these are very dangerous for the liquid uh, insulator. Okay, and dissolved gases. Okay, so gases can be dissolved in the liquids. I have given the example of the cold drinks. Okay, carbonated drinks, these are also called as carbonated drinks. Okay, the formation of bubbles and cavitations. Cavity means free space. Okay, so temperature and pressure of the liquid, the and the distance of the separation gap between the electrodes, these are actually they are talking about the electrodes of the test cell. Okay, we have test cell, so in the test cell we have two electrodes. Okay, so the gap, as the gap increases, the bubbles is going to increase. Okay, nature of the material, surface of the electrode, uh, it is also means that which material by which material the electrode is made, and it is also means that the structure of the electrode, that whether it is flat or spherical or Rogowski profile. This is actually the Rogowski profile electrode. Okay, surface of the electrode and viscosity. Okay, viscosity of the liquid. Viscous is the liquid, greater will be its dielectric strength. Okay, there are few theories that has been proposed for the breakdown of the liquid, and one is suspended particle theory, cavitation and bubble theory, and stressed oil volume theory. Okay, actually these temperature effects and the pressure effects, these will be discussed, and the bubbles and the cavities, these formation will be discussed in these theories. Okay, so these theory will be the part of our second lecture. So that is all for the moment, and we will discuss these theories in the next lecture. Okay, thank you.